In this video then, I'm going to be going through a few mole calculations. So these are straightforward, hopefully. These are fairly basic AS level mole calculations, just to give you a quick idea of, how to best tackle these questions, why we do them in the way we do, and what information you can pick out from the question and how best to go about setting out your answers. So whenever you look at these sorts of questions, there's always a lot of writing. There's always loads of writing, loads of numbers thrown in everywhere. But there's a few things that we need to pick out fairly quickly. And the first thing is what they actually want you to calculate. So in this case, it's very straightforward. They're asking you to calculate, the volume, okay, and the units matter as well, centimeters cubed. We'll get to the units later. I'm not sure it will be an issue in this question, but the units are important. They don't have to be centimeters cubed. And the final thing is that it's going to be produced at room temperature and pressure. Now that will make our calculation a little bit easier. So first things first then, we've been given an equation. Zinc and hydrochloric acid, zinc chloride and hydrogen. It's a very straightforward metal and acid reaction. And they're planning to react 50 of 0.1 mole per decimeter cubed HCl with 0.2 grams of zinc, which is in excess. And then you want to work out how much hydrogen is produced. So we know the amounts of our starting materials. We don't know the amount of our finishing material. Now, in terms of red herrings in questions, when you're doing mole calculations, if you ever see the words "an excess," it means there is too much of it. And it means there will be some left over at the end of the reaction, which means we can ignore it. For the purposes of this question, the excess doesn't matter. If you do make the mistake of working out the moles of the excess and using that to work out your answer, you're going to get it wrong. Because at the end of the reaction, you're still going to have some zinc left over. There's too much of it. So working out the moles of zinc is a bad idea. What we need to do is work out the moles of the limiting reagent. Okay, so the zinc there is just there to throw you off. The only bit that really matters is this. Okay, and that's the moles. That's the what's the moles? It's the concentration, the volume of the HCl. Now, hopefully, you will know what to do with this. Now, in every mole calculation question, this is a bit of exam top tip, really. They will always give you a way to calculate the number of moles of one of the reactants or products. Always. Whether that is giving you the mass in grams, so you can use the molar mass, or using volumes and concentrations, or a volume of gas at room temperature and pressure. They will always give you a way to work out the moles of something. So the first step in all of these calculations is always going to be working out the number of moles of the given quantities. So for HCl, uh, we are given 50 centimeters cubed and 0.1 mole per decimeter cubed. So from our from our equations, then we should know that number of moles equals concentration times volume. N equals CV. Standard fare here. Just got to make sure that the units match. So obviously I have decimeters in this one and centimeters cubed here. So in order to make this work, I'm going to need to convert the centimeters to decimeters. So I'm just going to do 50 over 1,000 to convert to decimeters and multiply by 0.1. So this is a fairly straightforward. This, a lot of these equations will be very straightforward mathematics. So you can probably do this in your head, but let's us not do it in our head in the exam, because you're obviously going to take a big risk by doing that. You may as well check it just to make sure you're right. But if you do this, obviously you're basically dividing by 10,000 at this point. So you end up with 0.005 moles. Okay, or 5 times 10 to the minus 3 moles. Either or, doesn't really matter. Now, what we do from here then is we have 0.005 moles of hydrochloric acid. So that's here. And we're looking for the amount of hydrogen. Now, the best part about moles is that when you know the number of moles of one of your reactants, you can work out the moles of everything because of the stoichiometry. So you know that 2 moles of HCl will produce 1 mole of hydrogen. Therefore, if I have 0.005 moles of HCl, I'm going to produce half the amount of hydrogen. So therefore, I'm going to produce 0.0025 moles of hydrogen. Stoichiometry, nice and straightforward. 2-to-1 ratio, divide by 2. The only thing I'm now left to do is to work out the volume. And luckily, it's at room temperature and pressure, which means we can use the molar gas volume. So we know that 1 mole of any gas, so 1 mole equals 24 decimeters cubed, or equals 24,000 centimeters cubed. So all we got to do to work out the answer in centimeters cubed is essentially multiply the number of moles by 24,000. So let's do that, shall we? 24,000, and we get 60. So in order to work out the volume, so V equals number of moles times 24,000 in order to get it into centimeters cubed, which is 0.0025 multiplied by 24,000, which gives us 60. Nice round number, and our answer is 60. There we go. Nice and straightforward. Okay, if you're not familiar with these, with this, conversion, I suggest you go and look it up. Okay, so that the purpose of this isn't for me to explain how to do all this and explain what the formulas are. It's meant to go through exam technique. So if you are unsure with where I'm getting this from, you need to go and and look at where the equations are coming from. Right, number 2 then. This one is a little bit more complicated, but again, it's more wordy than anything else. I wouldn't say it's complicated. Students carried a titration, wants to work out the molar mass of A. Student dissolves 2.24 grams of acid, don't know what it is, in distilled water, makes it 250 centimeters cubed. They titrate 25 of that with NaOH, and we've got a titer given. Now, important points here. We have a starting solution of 250, and we're only using 25 centimeters cubed at a time. That will be important later. Everything else is normal though, and again, we're going to have a straightforward, what is the known quantity here? Okay, so first thing, as I said last time, what is the known quantity? I am given a concentration and a volume of sodium hydroxide. That's your starting point. Okay, is to work out the number of moles of NaOH that we used in the titration, and that's going to be concentration times volume. This will be a very, very common theme, I have to say, in these questions. 25.25 over 1,000, convert to decimeters as we did before, multiplied by 0.120. So again, nothing basically identical to the last question. Okay, even though it's got a different context entirely, it's the same thing. Okay, and we're just going to make that equal. It equals 3.03 times 10 to the minus 3. Okay, nice and straightforward. That's the number of moles of NaOH. Luckily, obviously, we're not given an equation, but we're given the next best thing, which is the acid reacts with NaOH in a 1-to-1 molar ratio, which means the number of moles of NaOH is the same as the number of moles of acid A, which is 3.03 times 10 to the minus 3. And all we need to do now to work out the molar mass is work out, using the mass here, what the molar mass is, mass over moles. Or you would think that, wouldn't you? Okay, just be careful, because I've deliberately omitted one little step just to highlight how easy it is to just skip to the end. Remember I said that the number of moles here, 3.03 times 10 to the minus 3, is the amount in 25 centimeters cubed. Well, the actual amount was 250. So we need to multiply this by 10 to work out the total number of moles in the original sample. So we have to times it by 10. Okay, and that will give us the number of moles of A in 250 centimeters cubed, which gives us 3.03 times 10 to the minus 2. Okay, obviously. Now we can use the mass. So now it's a straightforward calculation. Molar mass equals mass over moles. We have both of these numbers. We have 2.24 divided by 0.0303. Okay, which is, this is where obviously I need to get my calculator out. 2.24 over the answer gives us a grand total of 73.9. So essentially 74. I'm just going to round to 74. And there you go. Nice and straightforward. 74. Okay. You can't, obviously, I've rounded. Don't do that. Put 73.9. But frankly, It doesn't actually tell you in the question how many sig figs he wants and how many decimal points. So in my opinion, 74 is a perfectly fine answer. Okay, so moving on then. Final bit then, only 2 marks for this one. Okay, looks complicated again. Look at the question. They give you an absolute ton of writing, but in reality, it's really straightforward. Blah, blah, blah. The first sentence is irrelevant. The only number I can see in any of this is this one, 0.08 moles. And would you look at that? They've given us the number of moles of aluminium. No calculation required. So the amount of moles of aluminium is here, 0.08. What am I looking for? The volume of hydrogen gas formed. Well, I'm looking for hydrogen, which is over here. It's a 2 to 3 ratio, which is a little bit, I say tricky. It's not really tricky. 2 moles of aluminium produce 3 moles of hydrogen. So divide by 2 times by 3. The amount of moles of hydrogen produced by this reaction will be 0.12. Okay, it's 2 to 3 ratio. And then I'm looking for the moles, the amount of gas in decimeters cubed at room temperature and pressure. So remember from last time, the volume equals the number of moles multiplied by, and because I want decimeters, I'm going to multiply by 24. So therefore, I need to do 0.12 times 24, and I get 2.88. And that's my answer. There you go. That question took literally about 10 seconds. But look at all the wording, look at the writing they put down. There's only one relevant number, and then you've got to quickly do the stoichiometry and one calculation, and you get 2 marks, and you can move on with your life. Okay, so brilliant. Hopefully that was useful, give you a bit of exam technique based on mole calculations. There's loads and loads of other more complicated mole calculations questions and amount of subs questions that I'll cover in later videos. But for now, it's just a quick little introduction to exam technique on amount of substance questions.